Okay guys, today I left you with an assignment where you were supposed to create tables to solve systems of linear equations. And I know most of you probably want to use substitution or another method we've studied, but we need to be versed in all the methods because they can be beneficial at different times. So on the number one, hopefully you were able to come up with the equation. We have two equations here, one for any time and one for talk more, where y is going to represent the total cost and x is going to represent the number of minutes. So for any time, our equation was 4.8 plus 0.05x, and for talk more, our equation is 0.09x. Now, on the first one, you were given values to plug in, and when you plug them in, you should have noticed that at 120 minutes, we have exactly the same cost for both plans. So the solution to this, where would the two plans be the same, which is what the question asks, the solution is right here, where they're the same. It's the point 120, 10.8. And that satisfies both of the equations. This solution means that both plans charge $10.80 for 120 minutes of long distance. Now, in the second one, you weren't given as much information. This is about the cat and the bunny, and the bunny's weight is represented by 5 plus 3x, where x represents the number of years, and y represents the total weight. And the cat is represented by y equals 19 plus x. So if we said 1, 2, 3, 4, all the way up to 7, which if you did that, then it would have fit on your chart, you'd see at year 7, they both are quite overweight at 26 pounds each. So what would this mean? This would mean that in 7 years, the cat and the bunny will both weigh 26 pounds. And here it says locate the solution on the graph also. And if you have not done that yet, I would like you to do that using technology. Now, the last one I'm going to show you technology to do it, and then show you something kind of neat that I want you to go back and practice with 1 and 2 also. On number 3, this is about the moving companies, and hopefully you were able to get the correct equation. Peter's pickup is represented by 68 plus 0.4x. Helen's haulers is represented by the equation 23 plus 0.65x, where x represents the number of miles and y is the total cost. So I made a chart here, and it took me a while to figure out what my independent variable needed to be, and I didn't label it. I should have. This column represents the number of minutes, and these two columns represent the total cost. So for what distance would the cost be the same? Well, they're the same right here at 180 miles, and that equivalent cost is $140. Which company charges a lower fee for 160 miles? Let's look at 160, and it's Helen. And then this one, which one would move a greater distance for 200? Well, I have the answer Peters, and let's go and see why now. Go along with me on your graphing calculators. You should all have a graphing calculator in your possession. If you don't, please ask the sub to hit pause at this moment and grab a graphing calculator, and then when everyone's ready, let's press play. Okay, so what I'm going to do is enter the two equations. 68 plus 0.4x represent Peters, and then we'll do 23 plus 0.65x is going to represent Helen's. Now, if we look at our graph, can we see everything? I do, and it looks like it's narrowly focused in here for me, and yours might be very different. So mine has the scale from yesterday's problem, so it went up to 2200. So let's bring that down a good bit. Since we do not have a negative number of miles, 0 is still a great minimum. But maybe let's do 300 for a max for our x, and 300 for a max for our y. And let's see how this looks. See if that helps any. Now that's a nice looking graph, and I can see the intersection here. So hopefully you were using your technology and you practiced our directions that were on yesterday's sheet, and you hit the second button and the trace, and you did choice 5, and you hit enter, enter, enter. and you found the solution was 180/40. Now, if you look right here, do you see I have a table? You also have a table. You just don't know where it is. If you look right above the graph button, do you see table? So if I hit second and graph, it gives me the table on the graphing calculator. This first column represents Peter's, the second column represents Helen's. Now, I know I need to go up to 180, so this counting by ones would take forever. But we can change how our table is set up. If you hit the second and the window, second and window, that gives you table setup. It asks me where I want to start. Well, let's start with 0. And since I've already looked at the graph, I know I need to go up to 180. Maybe let's count by 20s. So the change in the table is what you're counting by. And then we'll just leave it auto, auto. And now if we hit second table, it changes the setup. It's counting by 20s. And so I still can't see what I need yet. So if I arrow down, I get the values that I need. There's the 140 where they're equivalent. Not the 140, excuse me, the 180. A little further. 180 where they are equivalent. Now one of the questions asked, and this was the last one, which company will move a greater distance for $200? So let's come down here and see if we can find 200. Oh, we've already found it for company Y. So it's somewhere between 260 and 280. So that's for Helen's haulers, right around in here, somewhere between 260 and 280 miles. But do you see that for Peter's pickup, we don't hit $200 until somewhere between 320 and 340. So this table is very nice. What I'd like you to do now is go back to those first two equations. Enter the equations here. So we'll do them to the first one. Let's go ahead and clear all that out, clear all this out. Let's go back to that first one about any time long distance, and this was 4.8 plus 0.05x. And remember the x button is here. And then our second equation was 0.09x. Now, my window needs to change. Well, maybe, let's take a look. Yeah, my window needs to change. See how squished it looks down here? My y's didn't get very big. So my y's don't need to go up to 300. This cost on my chart maxed out at 1620. So I'm going to let it just go up to 20. And let's see if it's a better view. Oh, now that's a beautiful graph. So I can see that the intercept here. So now let's go check out that table. If we hit second and table, well, I just told it to count by 20s. And on your paper, it was counting by 30s. So let's go change that. Let's say, okay, I want to start at 0 and count by 30s. And now, let's take a look at the table. It's exactly what you needed for your problem. So on your own, please redo number 2 using the calculator. And then your homework is on the back of this sheet. You may practice using the graphing calculator while you're in class, and then you'll have to do the rest without the graphing calculator at home. Excel spreadsheet would also work for this, and we can talk about that another day. And we'll see you tomorrow.